So just to quickly introduce myself, my name is Ray, and I'm going to be giving all of you some more information as to what exactly is USACO and competitive programming in general, and why it's important, basically. So without further ado, I'll pull up my, let's get started on first, just exactly who I am. Like I said, my name is Ray. I'm a CS and math double major at the University of Virginia. And my experience with competitive programming, or just programming in general, my journey started when I was the summer before my ninth grade. In other words, the summer before I entered high school was when I wrote my first line of code. And that was kind of my first real exposure towards coding in general. And from going from that point to qualifying for the Platinum Division in USACO, which is the highest division you can achieve, I was able to achieve that in 10th grade. So in other words, from my experience at least, I was able to go from learning how to code to qualifying for the Platinum Division, probably within a year and a half, maybe a little bit over that. But yeah, I think this is a pretty good example and a pretty good time to say that anyone can succeed in competitive programming or USACO so long as you put in the effort and you try hard enough. Because as for me, I didn't have that much experience, but I've managed to be pretty successful in competitive programming. And some other qualifications or awards that I've earned over the years is that I qualified for the ICPC North American Championships, which is the largest international college level programming contest. And I also finished in the top 3 teams in my specific region, which is a Mid-Atlantic region. I'm also a Codeforces master, and Codeforces is one of the largest international competitive programming platforms, and I'm ranked top 2% currently. And I also have a bit of a math background as well, specifically in high school. I've qualified for the AME 4 times, and I've also gotten on the AMC 12 Distinguished Honor Roll, which I believe is the top 2.5%. And that was my score in 2019. And throughout college, I've managed to pass like many technical interviews, including but not limited to Amazon, Google, Cap One, JP Morgan. So that's just a bit about myself. Let's go into exactly what competitive programming is. So competitive programming is basically a timed contest with a provided set of problems that should be solved with code. So if you had some initial confusion as to is competitive programming like similar to development or not, or what is it similar to? It's not really software development. I wouldn't say those two are quite related. I would best describe competitive programming contests as you're coding, but the type of logic that you have is almost like very algorithmic based or very math heavy, in the sense that if you're already very good at math, then it's very easy for you to succeed in competitive programming as well. And that's why advanced level contests such as USACO or ICPC often require strong mathematical abilities. And all of these platforms that I've kind of talked about, whether it be USACO is probably the most relevant to all of you guys, assuming that your child is in high school, then they probably want to be focused most on USACO. College students would be most focused on ICPC or Codeforces and so on. And the majority of these major platforms appeal to high school and college students. So if your child is currently in middle school, then getting them introduced to competitive programming is a great head start to once they enter high school, that's when kind of like their major season starts. But of course, you can start competitive programming anytime you want. So Why is competitive programming useful? Well, for starters, it's a great way to develop a programmer's mind. From my experience in my years of competitive programming, I found that because of all the problems that I've done and all of the practice I've did, succeeding in technical interviews and coding projects in high school and university has become comes very easily for me, since competitive programming has forced me to write code in such a large capacity. Like CS classes were very easy for me throughout my academic years. And this helps greatly, like I said, with both high school and college courses. And if you find success in like USACO or on-site programming contests, then that's also a great asset you can use in college applications. And specifically, if you're looking to get into a top CS school like CMU, MIT, Stanford, etc., having competitive programming experience will definitely put you a step above the rest of the applicant pool. So, and not only does it help in the high school and college stage of your life, but once you're applying to jobs after you graduate college, you're going to need to be doing a lot of live coding interviews if you're applying to say Google, like any FANG company like Amazon, Facebook, or Microsoft. And if you're already familiar with competitive programming and you're skilled at being able to code a solution to a problem within a very strict amount of time, then you'll have no problem succeeding in live coding interviews when you're applying to college or applying to companies. And of course, if you have CS experience, then with algorithms and competitive programming, and you want to go into CS research, say you want to like do like AI research or machine learning research, then yeah. Did someone have a question? I saw someone raise their hand and then.
Harry, I just asked everybody to post their question in the chat, and as you go on, but we're going to save the last 15 minutes for you to select some of them and answer from there.
Okay. All right. Sounds good. And so where was I? Right. Having competitive programming experience helps if you want to do AI or ML or even just algorithmic research post-college. So I think I got my point across. Competitive programming has its use in the real world, and it's definitely a very useful skill to have. So let's dive into the specifics as to the largest high school level programming contest, which is USACO. USACO stands for the USA Computing Olympiad. And if you're familiar with other Olympiads, for example, like the USA Math Olympiad or Physics Olympiad, or even like Bio and Chemistry, USACO is going to be just as relevant as those other STEM Olympiads. So you'll often find that people who do well in, for example, the Math Olympiad also have some sort of track record in USACO, and vice versa. People who have succeeded in the Computing Olympiad also find success in the Math Olympiad. And this is kind of why I think the USA Computing Olympiad is like unique in its own regard, because while it's definitely the concept of programming as a competition hasn't been around as long as, say, like competition math, it's still very relevant, especially in this modern day where we're making strides with like technology and coding. What the USACO format is. So every year you're going to have 4 contests. One is going to be in December, one is January, one is February, and one is March. And for each of these contests, you're going to have separate problems for bronze, silver, gold, or platinum. And no matter which division you're currently in for USACO, you will almost always have 3 problems to solve within 4 to 5 hours. This may sometimes vary, but usually it's a case that it's 4 hours. They might extend it to 5 hours if it's, for example, the last contest of the season and the problem sets are harder than normal. But yeah, just think of it as you're given only a few problems, and these problems may take a while to solve. So just be prepared for that. And for each problem, you're going to have a set number of test cases. So for example, problem 1 could have like 20 test cases, problem 2 could have 18 test cases, and problem 3 could have like 21 test cases, for example. You never really know exactly how many test cases there are, but I don't think that's super important to know because it's best to just focus on solving a problem anyways, because you won't know what test cases are being used to judge your solution. Because the whole point is you want to code a solution that works for any and every possible test case. And when you do a contest within each of these months, if you score high enough in that division, you'll be promoted to the next division. So for example, everyone starts in the bronze division. If you register an account, you're in the bronze division. Let's say December rolls around. The December contest is in like 2 to 3 weeks from today. And let's say you get a perfect score in the bronze division. If you get a perfect score, then you'll be promoted directly to the silver promotion, and then or to the silver division. And then you can do the problems in the silver contest. And then if you like do well enough in that silver contest, and you get to move on to the gold contest, and so on. If you get a perfect score in a division, then you get to do an in-contest promotion, which means that you can do the next level of the contest in the same month or in the same like time window. If you don't get a perfect score, then you won't be able to promote in that same month. But after that contest window is over, they'll determine a cutoff score. And if you're above that cutoff score, then you will also be automatically promoted. So for example, let's say that I got 1,000 in bronze, which is a perfect score. And in silver, I get the score of 900, which is not quite a perfect score, but still very good. Because I didn't get a perfect score in silver, I won't be able to do the gold contest in December. However, once the December contest window closes, and they announce the silver cutoff to be, for example, 750, because I scored above 750, I will also be promoted to the gold division. And this kind of pipeline works all the way up until you reach the platinum division, which is the highest scoring division you can achieve in USACO. And once you reach the platinum division, the pool of platinum competitors is the pool that USACO will determine the finalists of the season. So after all 4 of these contests of the year are over, they're going to select about 20 to 30 of the best platinum contestants of that year, and then they'll invite them to their training camp. And this training camp is similar to MOP, if you've heard of like the Math Olympiad training camp, except it's basically for computing Olympiad instead. And qualifying for this camp position is very prestigious, and it's like if you qualify for that, then you're in that shows that you're a very strong competitive programmer already. And then within this training camp, the top 4 campers are chosen to represent Team USA in the International Olympiad in Informatics, or IOI. In addition, it's also worth noting that the top 4 female participants are also invited to training camp to compete in EGOI, which is the European Girls Olympiad in Informatics. So there's a very good opportunity here for female contestants to succeed in USACO as well, because they get to go to the training camp through a different pipeline, which is the European Girls Olympiad. Let's go on to, and I'll just touch briefly on other programming contests that exist. I've mentioned ICPC before. This is the largest international college level programming contest. In addition, a lot of the companies that I've mentioned earlier, such as Google and Facebook, actually host their own programming contests. For example, Google Code Jam and Meta Hacker Cup are probably 2 of the most well-known ones. And if you do well in these contests, they offer like huge prize money and stuff like that. I think the first place winner of Google Code Jam gets like $25,000 or something like ridiculous like that. But yeah, they have like pretty good prizes for that. And obviously, if you do well in these contests, that's something that you can put on your resume or in your college applications as well. Codeforces is a platform that I really like to use, and I attribute Codeforces to most of my improvement or progression in competitive programming, just because of how many problems exist on that site, how many live contests they host, as well as just the community that's on there and how many resources are available for me there. And all of these contests that I've mentioned so far, for the most part, are virtual. However, there are some on-site programming contests aside from ICPC, such as those hosted by MIT, CMU, UCLA, UPenn, and of course my own school, University of Virginia. We also host a on-site programming contest for high school students, and some of these on-site programming contests are also available for college students. So obviously, if you're in high school, USACO is probably your #1 priority and is going to be your focus. But even after you graduate high school, there's still many opportunities for you to like find success in competitive programming and still find opportunities to compete. I should probably mention what the prerequisites are for taking a competitive programming class, or in general, like even starting your competitive programming journey. Obviously, because you need to program, you need to know how to program in a good programming language. That should be pretty obvious. I would say the 3 main languages that are useful are either C++, Java, or Python. And out of those 3, C++ and Java are definitely better than Python for competitive programming. And C++ is the most efficient out of these 3, because although C++ is harder to learn and a little bit trickier to understand the syntax for, because of the way C++ works, it actually runs more efficiently than Java, and Java runs more efficiently than Python. So obviously, if you're engaged in a programming contest that requires you to be as efficient as possible and optimize your solution to the fullest, you probably want to be using a good programming language for that. And of course, experience in competition math is not required, but it will be very helpful in your competitive programming journey. Oftentimes, you'll see like some topics in competitive programming are just straight up like math concepts. So for example, like there will exist some programming problems that require you to find the expected value of some quantity. And obviously expected value would be something that you could like learn more about if you were familiar with like AMC contests. I'll just give a brief overview as to what does a USACO class look like. So if you were to if you were to sign up for a USACO class with our school and I were to teach it, then this is kind of a general overview as to how I would run that class. And of course, it's different for every student depending on their skill level and how fast they're progressing. But generally, the first thing I would do is I would introduce them to a general algorithm or problem-solving technique. This could be something like dynamic programming or binary search or like greedy algorithms, or it could be like a specific topic of those broader subjects that I've just mentioned. It really depends on where the student currently is and how much experience they have and what aspects or techniques they need improvement on. And so I'll give them a general rundown on how this algorithm will work, and if they aren't familiar with that already. And once they're familiar with that algorithm, I'll start by providing simple examples for them to apply this algorithm. So for example, in this diagram, I have the algorithm for strongly connected components. And after I explain to the student how the strongly connected components algorithm works, I would give them, say, like this sample case with this diagram to the left, and ask them, what are the strongly connected components in this graph? And I do this to make sure they have a general understanding as to how that algorithm works, because at the end of the day, competitive programming is all about having a really sharp intuition. You have to make very educated guesses, and you have to make certain assumptions that you know are true just based on the past problems that you solved, or just based on like some sort of logic. Or you could even need, or you might even need to prove like some constraint is true. And those type of proofs have a very similar flavor to the type of proofs you can find in higher level math contests. And so once a student kind of understands how a simple example works, I would show them a harder problem that uses this algorithm. So, and this harder problem would constitute a problem from, say, a past Code Forces or USACO contest. And I would have them think about the problem for a little bit and see what ideas they have at first. And I like to run my classes hands-on because at the end of the day, if someone wants to succeed in USACO, they need to know how to come up with ideas by themselves and also like implement these solutions without any external help. And in my lessons, I want to foster that style of active learning as much as possible. So I don't want to immediately give away a hint or a solution to the student if they're capable of solving it themselves. So that's why I like to engage the students into solving a problem live. And every like few minutes or so, I'll make sure that they're on the right track. And if they seem stuck, then I'll give them a small hint. And a lot of the times, giving them these hints allows them to arrive at the final solution to solve the problem. And with this way of learning, not only will the student receive targeted and specific advice from my experience and expertise, but because they did most of the work in actually coming up with part of a solution and coding it themselves, this puts them in a great position to replicate that to replicate that in an official contest, because I'm not going to be there for them in an official contest. So they would need to have practice to do that. And of course, outside of classes, I will also assign problems for these students to work on for the week. And I'll also provide extra resources for these students. So for example, if we learned about the strongly connected components algorithm in this week's class, then once the class is over, I would also send them a link to maybe an article like describing a more detailed proof about the algorithm, as well as different variations of this algorithm and its applications. Like, how could you apply this algorithm in a more broad sense? So yeah. And I'm going to touch briefly on how I prepare for a programming contest. And after I get through the slide, I'll actually show all of you guys a typical competitive programming problem. So, how did I prepare for programming contests? Well, obviously, you have to do a lot of practice problems. If you want to be good at something, you need to practice a lot of it. And as you can see in this diagram, this was my submission list for the year 2020. And I solved a lot of problems in this year because this was my first year in college, and it would be my first year competing in ICPC. So obviously, I attribute a lot of my success to this consistent and rigorous practice that I've put myself through. And I honestly wouldn't have been able to have this much success in competitive programming if I didn't have friends or a mentor to guide me through. And my mentor in my case were my friends who were as good as me or better than me in competitive programming. I would talk about problems with them all the time. And if I couldn't solve a problem that they could solve, then I would discuss that with them and ask for like occasional hints until I understood how that problem was solved. And this type of active discussion really helped me improve my my ability to do well in contests. And another thing is that when you're practicing by yourself, you don't want to read the official solution like too early. You want to give a serious attempt and serious thought into every problem, no matter how hard it is. Because if you just look at a problem, immediately decide it's too hard, and then jump straight to the solution, you don't really learn anything from that problem. Even if you're not able to solve that problem in the moment, still give it your best shot, because that attempt, because your serious attempt to that problem will kind of tell you what are you doing right and what do you need to do better in like official like contests. And of course, you want to compete as many live programming competitions as possible, because solving problems just on your own free time is definitely different from solving in an actual live contest. I've mentioned Codeforces earlier in the seminar. Codeforces hosts live programming competitions like a few times a week. They're a really good resource to do. And that was a really good opportunity for me to practice competing in a live contest, which was especially useful when I was in high school because USACO contests only happen 4 times a year. And I wanted to have some sort of live contest practice more than 4 times a year for obvious reasons, which is why I turned to Codeforces for that. So yeah, before we go into a Q&A, I'm going to pull up a Codeforces problem. The problem statement for this is actually quite simple. You're given n-1 integers, like a1, a2, all the way up to an-1. And your goal is to construct an array of n integers such that these conditions hold. The first condition is that in the array that you want to construct, every integer from 0 to n-1 appears in B exactly once. And the second condition is that for every adjacent pair of indices in array B, the XOR of these two values will be equal to the corresponding value of the value at index A, where XOR is a bitwise operation. If you are familiar with how bits work, XOR will return true if the 2 bits are different, and it returns 0 if the 2 bits are the same. And this is a bitwise operator so that it works on these values in base 2. A lot of this might seem a little arcane or confusing to understand, And this is definitely a more complicated problem. If I were to see this in an official USACO contest, I would say that this particular problem would probably be of gold difficulty, which is the second highest division you can achieve. So if you already have these type of problems in a contest, then that means you're in a very high division already, and that you're trying to become the best of the best. But these are the type of problems that if you do want to find success in USACO, these are the type of problems that you're going to be encountering. And through your competitive programming journey, you would learn how to first, how do you approach a solution to this problem? What are the first steps you take? So, and what type of pre-existing algorithms or techniques would you need to solve this problem? In this example, part of my intuition is that I would need to use a data structure called a binary trie to solve this problem. And the reason why I felt that this was important is because just based on my personal experience, I've solved a few problems in the past that are of similar nature, and they were able to be solved with a trie. And that's like kind of the first step I can take to solving this problem. And then after I make this observation, I can implement the data structure itself. So this is a code that I wrote for this problem. This is where I implement the data structure, and these are the data structure operations that I use. This isn't an actual class, so I won't dive too deep into exactly how this works, but this is just a way for all of you to understand what a typical competitive programming problem will look like. And if you find success in competitive programming, you can expect to be able to solve these type of problems. And so basically, this is a problem that can be solved with this data structure. And once we create this data structure and add like some special features to check for certain conditions, we can build this array by finding the very first element of array B. And once we find a valid value for this array for B1, we can actually construct the rest of the array very easily by XORing B1 with A1 to get B2. And then we can combine B2 and A2 to get B3, and so on until we reach Bn. And this is possible because the XOR operator is commutative. So we can just basically XOR both sides here by AI, or by BI, my bad. But yeah, that's just a quick overview as to how I would approach this problem. And I would say for this particular problem, it would take a while before I would actually explain a problem of this caliber to a student that's starting in the bronze division. But if your student is already has a very strong mathematical background and can breeze through the bronze division very easily, then I think this type of logic would be very appealing to them, especially if they're strong in math, because a lot of this understanding behind how this data structure works is has a logic and flavor similar to a math contest. This is an example of what a competitive programming problem will look like. That's the end of my presentation. I'll take any questions now if any of you have any.
So how well you do in the competition, is that going to be counted for in your college application?
Yeah, of course. That's a very good thing to write on your college application, especially if you get a high score in one of the higher divisions, like the gold or platinum division. And if you achieve a high score in a division, that will also promote you to the next division. So, for example, if you're promoted up to the platinum division because you succeeded in the gold division, you're already in like the top like 5% or so among all high school students in the US. So being in that division itself is a very good thing to put in your college applications. And schools that have like strong competitive like programming teams or strong like CS programs will definitely weigh that heavily when you're applying.
I got another question, which is Chinese. I'm going to try my best to translate that. So when you submit the application, when you submit your coding, how is it actually being scored? Is somebody actually looking at your code to come up a score for your algorithm, or the count by the time that it took? And if you mentioned that you do not prefer Python, is it because it runs slower?
Yeah, so all of these competitive programming contests that I've mentioned, they all have an automated grading system. So you just submit your code and then some like program on, basically they'll have a grading server. Your code is sent to that grading server and the server will automate the process of running all the test cases on the server. And then once it gets the result of these test cases from your code, it then returns the results of the test cases to you. And part of the reason why I say Python is not a preferred programming language is that is because it runs slower. And a lot of these programming contests will have a time limit to every single problem. So not only do you need a solution that is correct in all the test cases, but you also need a solution that runs within the time limit. So yeah, this is why I recommend not using Python in the long run, and that why it's best to use specifically C++, because C++ is the fastest language that can be practically used for competitive programming contests.
Thanks for explaining that. So one thing that I have, it comes to my mind is we have a lot of students starting from elementary school, they start learning Python. They don't start by learning Java or C++. They may start learning Java once they get to a high school level. But so for those students, for example, they're in middle school, they have learned a couple of years Python, but they haven't really learned C++ or Java. Do you still recommend them to take on Java or C++, or do you recommend them to go with Python to the lower division, and if they reach a certain level, then switch to different programming language?
I would say that it's totally fine to learn Python as an introductory language, and specifically for an elementary school level, you can definitely succeed in the lower divisions of USACO with Python. Specifically for bronze and silver, there's almost like no issue in using Python. Only once you start getting to the gold division would I say like there's a tangible difference between using Python and using Java or C++. And once you achieve that level, then you might want to consider making a switch. But to code well in Python, then learning Java or C++ well enough to use in coding contests shouldn't be too much of an issue either.
Got it. So since we're on this topic, just for everybody's benefit, what language do you use to get into a platinum division?
So I use Java to promote myself to the platinum division. Sometimes I will also use C++ if it's very necessary, but I often find that Java, if implemented efficiently, can pass almost any that I solve.
So the next question is tightly related to this, because you mentioned you start writing your first line of code in 9th grade, right? And you were able to get into the platinum division within 2 years. So I got a question mentioning that and saying, how did you improve so much? How do you improve so rapidly in such a short time? Do you have any secret there? For example, how much time do you spend on this every week or every day?
So when I was really invested in doing well in USACO, I spent like a lot of time every day, especially when I was in the early learning stages. I would say I spent maybe like at least 2 to 3 hours every single day just practicing, and more on the weekends if I had time. And a lot of that practicing was just solving problems and reading like online like articles or watching videos about certain topics. Um, as I as you've seen in this slide over here, on Code Forces alone, I've solved like almost 3,000 problems in my entire lifetime. And obviously, I've also have solved problems from USACO resources as well as like ICPC. So yeah, I've definitely solved a lot of like programming problems within these past like 6 to 7 years of like my competitive programming journey. So in the end, I really think it's comes down to not only practicing a lot, but also knowing how to practice efficiently, and also having the proper resources such as online resources or a mentor to guide you and lead you in the right direction so that you use your time as efficiently as possible.
Got it. So I do notice that it says 41 days in a row max. Does that mean you practice nonstop for 41 days? That's the maximum nonstop days you have?
Yeah, that means this submission map is just for Code Forces. So this means that in this year, I had a streak of 41 days in a row where I solved a problem, or like every single day on Code Forces. I think during the specific year of 2020, I also did a lot of like problems on the platform hosted by ICPC. So a lot of the problems that I've done for ICPC aren't necessarily reflected on Code Forces either. But the bottom line is I did do a lot of practice like in my lifetime.
Absolutely, absolutely. So kind of related to this is there are multiple stages you went through, starting from the lowest division. And one parent is curious how much time you spend in each division. For example, is it very easy to go through the first couple of stages and you spend a lot of time to conquer the last two stages, or you started really slowly, but at some point you kind of break through. Can you explain how that worked out for you?
Mm-hmm. Yeah. So I went from the bronze division to the silver division in my very first contest. I think doing well in the bronze division just comes down to like being able to code proficiently and having like basic like logic skills. So you don't really need to practice a whole lot to promote into the silver division. However, promoting from the silver division to the gold division requires you to understand like certain algorithms and like optimizations. And for me personally, this was actually the hardest division to get out of. I spent within like that freshman to sophomore year of high school, I by far spent the most time in the silver division, just because the jump from bronze to silver is a very high jump. And once I finally made that jump out of silver into gold, once you get into the gold division, you already have a sense of how to do well in programming contests, as well as how to learn like algorithmic techniques. So long as you carry that same momentum forward, it's actually not super difficult to go from the gold to the platinum division if you put in the same consistent effort that you use to go from the silver to the gold division. So once I entered the gold division, it took me, I think, either 2 or 3 more contests for me to pass the gold division and qualify for the platinum division, which is the highest division you can achieve in USACO. So yeah, that was my time frame for these 4 divisions.
That's very helpful. I think it's for parents' benefit. I think they can really see that what does it take to get there. I think you have this little graph here. Initially, I thought it was for decoration, but that's actually all the effort you put in. It's very impressive. So on that, I also have a related question: that what actually drove you with all these efforts? It looks like you have really putting a lot of commitment to this. What made you do that? Is that just you're just self-motivated, or is there a strong drive for certain things that actually made you, putting so much time and so much efforts and really try to do well in this?
Honestly, I just found USACO to be very interesting, or it's this competitive programming in general. I just found it to be very fun because especially in my freshman year, I was just starting to learn how to program. So I think the idea of like being able to program in a competition and like be like scored for that was very appealing to me because I enjoyed doing like math competitions as well. So and I was just trying to like gauge like how competition programming was. And once I realized that it was very similar to the type of logic and skills you would need in a math contest, but it's also different because you need to code a solution and write the solution with no bugs, and you also have to think of ways to optimize and be efficient. And that in itself lends itself into its own problem solving like niche. And I just thought it was a lot of fun to see myself improve as I practiced more and more.
I have a question about what is a math knowledge you have to break down for each division. You mentioned that basic logic is needed for browse and the certain algorithm needed for pseudo. But is there direct mapping of what type of math knowledge that you need to have to encounter each division?
There's some like math knowledge that is very useful to learn, but a lot of it isn't necessarily required. For example, for the bronze division, you definitely don't need like a whole lot of math knowledge because bronze division just kind of tests your ability to code like a basic solution. In the silver division, I think having some familiar being familiar with like number theory basics like prime factorizations or like number theory and like greatest common divisors is useful to have in silver, but is not like necessary because while those concepts will appear like frequently in like specifically like other contests, they only appear like every so often in USACO. But it's still good to have that knowledge in the event that they do appear. And once you get to gold division, that's when you really need to have strong math knowledge because the gold division is when they'll start to ask questions about, say, like expected value or like expected probability or writing some sort of like linear recurrences and stuff of that sort. And that knowledge for probability theory is applicable in gold as well as platinum. So math only becomes like necessary once you start getting to the higher divisions. But if you have aspirations of doing well in platinum and qualifying for camp, then I think your math knowledge needs to be strong enough to at least qualify for Amy.
Got a technical question about when you test your solution, when you write your code, do you have a simulator or compiler that can use?
For these programming contests, you can always test your code locally. You won't have access to the test cases that the system will use, but you can generate your own test cases and test those test cases by yourself to see if your solution works on them. And sometimes, especially for USACO, they'll even provide a sample test case or two for you to test your solution on to check if it's correct or not.
Question asking if you feel any challenge in managing time for other subjects. I guess he's trying to ask about how you balance out, the busy high school life. And since you spend so much time here in competition.
Yeah, so it definitely was a challenge to balance like just not only my school life with competitive programming, but also like other extracurricular activities. I think that's definitely more of a general question on how do you manage your time and not so much specific to just competitive programming, but I think establishing a routine and keeping yourself motivated to do something is always a good thing. And having this routine of like solving problems like frequently for me has definitely helped because so long as I'm solving problems on a consistent basis and these problems are of like a high enough difficulty, I'll always be learning something every day. And even if like someday all the problems I solve feel like easy to me, then that's just a way to keep myself sharp and allow myself to not like um not regress in my improvement.
I do have a mom asking me that if you have any sports or instrument that you play, or any club that you participate. I guess they just were trying to understand how you really decide whatever you put in where.
Okay. So I used to play the cello, but I haven't but I kind of stopped playing that in college just because like I couldn't really bring a cello on grounds and it was I just didn't like have as much time for that. One hobby that I do participate in a lot is like solving Rubik's cubes and like competing in like those like Rubik's cube contests. I actually have like a pretty good track record in that. I like win like those contests like pretty frequently. That's like a pretty like big hobby of mine that I like to do. But yeah, that's like those are probably like the major things that I've been up to recently. I've done like more things in high school. For example, like in high school, I actually qualified for I was I was a semifinalist for the USA Biology Olympiad because I studied like AP Bio and like beyond at my school, and I was like good enough at bio to um, qualify for the next round. And I've also found success in um, I've also like found success in like more leadership opportunities as well. In high school, I was like one of the officers for my computer team, and college I've like also like remained active in like the CS organizations, specifically the one that hosts the on-site programming contest like I mentioned earlier.
Thank you for clarifying that. So 3 Olympiads that you participated in and did very well. Congratulations on that. So since we had a mom ask a question, I'm just going to ask, what has been your parents' involvement in you achieving all this? Because, for example, you started coding in 9th grade, which is really not the early age. So I'm curious that why didn't they introduce that earlier to you, and what is your advice to our parents in tonight? That do you recommend to them to start coding in the earlier age, or do they recommend them to actually do serious coding only starting in middle school or in high school? What is your take on that?
I would say my parents' involvement was typically my dad really like wanted me to at least start like learning how to program before high school. There wasn't a huge emphasis on the competitive programming aspect, although he did introduce me to it, but he only really like quote unquote forced me to learn how to code. There wasn't like too much like I think like my interest in like actually competing in like programming contests once I learned how to like code fundamentally was mostly like my interest and like my ability to, and also because I had like a strong like background in math contests leading up to that point. So yeah, a lot of this practice that I did, my parents, they've like signed me up for like similar like courses like this in the past, and those have definitely helped in my improvement. But the majority of my progress definitely comes from like me putting an effort like in my own time, and in those classes, or like when I meet up with mentors or friends or whatever, like talking about like our progress and like what we were stuck on that week and what can we improve on and stuff like that.
Self-motivated kid is always the best, right? And I do have a question about, can you qualify into higher division multiple times in a year? I guess you kind of explained that earlier, that you could, even in the same month, you could qualify to the next level and you could get a perfect score.
Yes, that's correct.
Yeah, so it's possible that in the same year, because there are 4 times in December all the way to March, and 4 times you could go all the way to platinum if you get it right.
Absolutely.
So what kind of algorithm are important for each level or division? Can you name maybe?
Yeah, I'll keep this brief, but for bronze, you don't really need any specific algorithms, maybe just like very basic data structures such as arrays or maps. For silver, knowing binary search, like tree sets or greedy algorithms are very useful. And also knowing like DFS and BFS, as well as like basic like graph and tree theory is useful for silver. Once you get to gold, you'll want to learn more advanced graph or tree algorithms, such as shortest path or lowest common ancestors, or strongly connected components. And in the gold division, that's where you'll also experience more complicated dynamic programming problems that require more nuance and like more thinking behind them. And a lot of these dynamic programming problems are also related to probability or expected value. And in the platinum division, there's a lot of like problems in the platinum division that either use a lot of these algorithms in one problem, and you have to kind of know when to apply each algorithm, or the problem itself is so unique that it doesn't really, it's not super similar to a pre-existing algorithm, and you almost have to come up with a unique solution on the spot. And those type of problems are like quite tricky because you have to really know how to build a solution from scratch.